Alright, this video is on different ways to write chemical reactions. There are three main ways I'm going to have you write reactions. One of them is a molecular equation where we have all of the species written as the chemical formula in the equation. We also have the complete ionic equation, which is the molecular equation, but the ionic compounds within the molecular equation are broken up into the ions. And then lastly, we have the net ionic equations. Okay, I'll go over a few examples of equations, and then I'll give you the molecular, the complete ionic, and the net ionic for those equations. So let's go ahead and take a look at an example. All right, let's go and take a look at sodium chloride and silver nitrate. So very first thing I'm going to do is the molecular equation, which I will write out the whole reaction. So I start with sodium chloride plus silver nitrate, and you can use your tables to figure out your equations for right now. And I'm going to form, this is a precipitation reaction, so I'm going to flip the metals in this case, because I'll have silver chloride and I'll have sodium nitrate. Okay? Now, this is where we're going to start paying attention to the parentheses, you know, after each one where we start talking about the states of matter. Okay, because now that you know how to write or how to determine if something is soluble or not, now we can start labeling it. So this is sodium chloride, and it is aqueous, as is the silver nitrate. It is aqueous. Okay, and if you look at your solubility tables, you'll notice that your solubility rules, you'll notice that silver chloride is insoluble, so it's a solid. And then sodium nitrate is aqueous. Okay, so that right there is the molecular equation for the reaction of sodium chloride and silver nitrate coming together. Okay, so just kind of a refresher memory, if I was to have a beaker here and a beaker here, and let's go ahead and say they were added together. Okay, so inside the first beaker, okay, so beaker 1, beaker 2, and then beaker 3, let's say I poured beaker 1 and beaker 2 into beaker 3, I'm going to have inside here some sodium ions and some chloride ions. In beaker 2, I'm going to have some silver ions and some nitrate ions. And then when I add them together, I'm going to end up with some sodium ions, some nitrate ions, and then I'm also going to end up with a solid. And that solid is going to be silver chloride, because silver chloride is insoluble. All right? So this is the, like I said, the molecular equation. Now let's go ahead and take a look at the complete ionic, in which we will break down all of these different ions. Okay, so the complete ionic equation, let's go ahead and make that a different color. Oops. The complete ionic equation is going to be, remember it was sodium chloride, so sodium cation plus chloride anion plus silver nitrate, which is the silver ion, plus the nitrate ion. Okay, and then it'll react, and I'll go ahead and draw the arrow right here, okay, and then draw the products below it. I'll end up with the sodium ion, the nitrate ion, okay, so NO3 minus, but I'm also going to end up with a product, a solid product, silver chloride. Now again, I need to write out what they are. So all of these are AQ. That's a horrible A right there. AQ, AQ, AQ. The product's AQ, AQ, and then this product is solid. All right? Now, the last type of equation, remember, okay, so first we had our molecular equation, which we had the formulas written as they are, they're not ions. And then now the complete ionic, we have all the ions here broken up. And then, of course, when we form our solid, we have to write it in as is, okay? Because it's not aqueous anymore, it's a solid because the sodium chloride's insoluble. The last one is going to be the net ionic equation, which honestly is just like the complete ionic equation, but we're getting rid of something called spectator ions, meaning these are ions that are they're in the solution, but they're not involved in the reaction. Okay? So, pretty much how I identify a spectator ion is if they are on both sides of the arrow. So I see sodium plus aqueous on the reactant side, and I see sodium plus aqueous on the product side, which means this is a spectator ion. I'm going to get rid of it. Okay, see if we can find another one. The chloride ion is not found on the product side, so it is not a it's not a spectator ion, nor is the silver one, because the silver and chloride came together to make a solid. It's not an aqueous solution anymore. It's not just an ion. Okay? The nitrate ion is on the reactant and the product side, so it is a spectator ion. All right? So if I was to draw the net ionic equation, I just need to identify what I have on my reactant side that's left, which is this right here, and what I have on my product side, which is this right here. So the net ionic equation is going to be Cl minus, okay, which is aqueous, plus Ag plus silver, aqueous, forming AgCl solid. Okay, that's the net ionic equation. Okay, so we'll do one more example. Okay, so we have potassium permanganate and copper 2 sulfate. Both of these are aqueous. So if I was to write out my molecular equation, I would be potassium permanganate, which is aqueous, plus my copper 2 sulfate. Copper 2 sulfate. Sulfate's a negative 2 charge. That's also aqueous. And it's going to form, okay, the product that's going to form is, remember, I'm just going to switch the products. So I'll go, switch my metals. Okay, so I'm going to go potassium sulfate, which is aqueous, plus copper 2 permanganate, which is going to be, and I'll go ahead and draw it down here, copper 2 permanganate, so I'm going to go MnO4 2. Now this is a solid. Okay, so let's, first of all, something should pop out at us and things aren't balanced. Okay, over here it looks like I have 2 permanganates because that's what's needed over here to make my copper 2 permanganate neutral or balanced or neutral. So I need to have 2 permanganates, and actually I need to have 2 potassiums as well. So I should have, I'm out of room right here, but I should have a coefficient 2 right there. Okay, and that'll balance things out. So this is the molecular equation for this. All right. Let's look at the next thing. Is going to be the complete ion, the complete ionic, which would be 2 potassium ions plus 2 permanganate ions. So I'd have MnO4 minus. Okay, and the reason why I know it's minus is A, because it was with potassium in a 1-to-1 ratio, but also I can look at the table. Okay, now keep in mind these are aqueous, aqueous. Okay, my other reactant was copper 2 plus, which is aqueous, and then my sulfate ion SO4 2 minus, which is also aqueous. So my products is going to be a flipping of the two. Remember, I did form a solid with the copper permanganate, or copper 2 permanganate, so I can write that one first. So copper permanganate, which is a solid, plus my I had 2 potassium ions, which were aqueous, and I also had I had 1 sulfate, 2 minus, that was aqueous. Okay? So, that's my complete ionic equation. And then lastly, if I wanted to find out what my net ionic equation is, okay, I will simply remove the spectator ions. So on the reactant side and the product side, I have a sulfate, and I have 2 potassium ions. So those are gone. So my net ionic equation is going to be 2 permanganate ions, which are aqueous, plus a copper 2 plus ion, which is aqueous. And I'm going to form copper 2 permanganate, which is a solid. All right? Now, one important fact, if you do an equation like this, or a reaction, and both of the products are still soluble, meaning there was no solid formed, it's very important that you know that there was no reaction. A reaction did not take place. All right, so if a solid formed, then you have a precipitation reaction, because there was a forming of a precipitate. But if, like for example, if copper permanganate was soluble and was able to be dissolved, then there would be no reaction. It would just be a combination of ions in a beaker. Okay, it's very important that you realize that it's only a reaction if a solid forms. Okay? If you guys have any questions, please email me.